Welcome to Weather Extra on CBS News Bay Area. I'm KPIX5 meteorologist Paul Hagan. We use these segments on CBS News Bay Area to do a deeper dive into weather and climate topics, a longer look than we can do within our on-air segments on KPIX. And I want to talk more about El Nino because it continues to look more and more like we are going to be getting into El Nino conditions as we head through the next several months, which has an impact on weather patterns, not just where the warm ocean water that defines El Nino exists over the equatorial Pacific, but around the entire world. And we're already seeing some hints of that. We're seeing an even stronger signal that that warm ocean water is beginning to become even more intense. You can see this stripe that extends away from the coast of South America. On the globe here, we have portrayed sea surface temperature anomalies. So how far above in red and orange, or how far below are these ocean surface temperatures compared to where they ordinarily average out. And you can see that stripe of above normal temperatures that does help to define El Nino, but it's only one of a few different factors. Now we have increasing confidence that now that we're in El Nino conditions, we are going to continue to be in El Nino conditions for not just the next several months, but for the next few seasons. High confidence, over 90% confidence that we're going to be remaining in El Nino, not just through the summer and into the fall, but into the winter, which is typically when those El Nino conditions do peak. So let's take the virtual reality bars off of the map here and talk about this criteria. How do we evaluate whether or not El Nino is here? And this is the flow chart that's used by the Climate Prediction Center to make that evaluation. So you start with, is the sea surface temperature anomaly at a certain threshold, 1/2 degree Celsius, which doesn't sound like a lot, but when you're talking about a body of water the size of the Pacific Ocean and that area of warmer than average water, that's a big enough difference to have a big trickle-down effect farther downstream. Then, do you think it's going to stay at that level or get even stronger for not just the next several months, but for the next several seasons? And then you look at, what does the atmosphere look like? Is the presence of that warm ocean water already having an impact with the flow of weather through the atmosphere near where the warm water exists, and even farther away from that, farther around the entire world? So let's take those one by one. El Nino exists because we have seen a change from late January in early February in this area that we monitor for the El Nino conditions, from slightly below average sea surface temperatures, a La Nina event, a brief period of neutral conditions shaded in white, and now the above normal sea surface temperatures taking over. It's just reached that 1/2 degree Celsius threshold, but there's high confidence that we are going to stay in those El Nino conditions. That's the second criteria, because there is a lot of warm water below the surface that's going to bubble up and help to intensify the already abnormally warm conditions in the equatorial Pacific. So again, you can see how brief the period of neutral conditions has been. There's a lot of warm water below the surface that is going to just have an exacerbating impact on how far above normal those temperatures are already. So that's category 2. High confidence it's going to continue. Are we seeing a difference in how the weather is behaving? This gets a little bit more complicated. Usually, the way that the weather flows over the Pacific is what we call a Walker circulation. So usually there is warm water over the Western Pacific and cooler water over the Eastern Pacific off the coast of South America. That means where the warm water is, it tends to feed convection, thunderstorms. This is where the rainforests of much of the Western Pacific exist, because it's typically a rainy pattern on a normal basis. You get sinking air where that cold water exists. But when you put where the warm water in a place where usually there's cold water, you disrupt this Walker circulation. And we're already seeing signs of that. So now we're seeing the showers and thunderstorms developing much farther away, thousands of miles away from where they typically develop. Now you're getting sinking air where usually it rains. Now you're getting thunderstorms developing where it usually doesn't rain. This affects the flow of atmosphere around the entire world. Think of if you just took a stream that was flowing downhill, took a big boulder and dropped it into the middle of that stream, the water has to flow around it. It's going to find a different way to go downhill. The atmosphere is a fluid. That's kind of the stream analogy here. It's going to find a way to flow around that boulder, which is the increased presence of those thunderstorms in a place that they usually are not. And that flows all around the entire world. So we're seeing disruptions that exist already in the form of a very active subtropical jet stream. This is the typical El Nino effect across the United States. This usually happens wintertime with a signal towards wet conditions in the desert Southwest and Southern California. The Bay Area, we talked about this last month, we're typically on the edge of whether or not we get wetter than normal conditions or just near average rainfall. But the active subtropical jet stream usually doesn't kick in until we get into late fall and winter. We've had recently this outbreak of severe thunderstorms through Oklahoma and Texas into the Gulf Coast states, something that usually happens in January, February, maybe March. This time of year, usually that severe weather threat is drifting much farther to the north as we head into early summer. Instead, we have seen this subtropical jet helping to feed those thunderstorm outbreaks months after they usually occur. So even though the peak of these El Nino conditions usually occurs during the wintertime months, especially with that rainy signal towards Southern California, we're already seeing the impact of those developing El Nino conditions in the Pacific. And we have high confidence, not just that 95, 96% confidence that we are going to stay in El Nino conditions all the way through the fall and into the winter, but there's significantly over a 50% chance that this is going to be a strong El Nino event, similar to the conditions that we had back in 2015, 2016, 1997, 98, and 1992, 1983. The new long-range outlook from the Climate Prediction Center also just came out. This is for December, January, and February, so that does actually take us into winter. And look, it matches up almost perfectly with what we typically expect of El Nino conditions, wetter than normal conditions for Southern California and the desert Southwest. No strong signal for the Bay Area and the rest of California because, again, things can go either way. One of our wettest winters on record was that winter of 1997-98, but the last strong El Nino, 2015-2016, we had almost exactly normal rainfall around the Bay Area. So it could go either way. It's something we'll continue to evaluate as this latest El Nino event develops. Every one of them is a little bit different, so we're going to have to keep an eye on the latest trends. And of course, climate change is the heavy foot on the accelerator of everything that happens in the atmosphere. We'll be watching that. We'll also be covering other weather topics here on CBS News Bay Area. If you have a weather or climate question that you want to ask us and we can answer here, just email that to us at weatherextra@kpix.cbs.com.